rule number 1 goes as follows. Okay, so the rule is if we have a to the power of m times a to the power of n, because we are multiplying, okay, we need to add the exponents. All right, so this is going to look like this at the end of it. A to the power of m plus, that is your rule. So let's quickly hop into a easy peasy lemon squeezy example just to demonstrate this so you can get the gist of it. So let's say we have x squared times x to the power of 3, right? Because we are multiplying, right? Our bases are the same. We are going to add these exponents. Cool. So this is going to look like this. X2 plus 3. And then we can simplify that as x to the power of 5. And that then would be your answer. And that is the first rule done. But what I'm going to actually do is do a second example here, just so we can get the gist of this here. So let's say you have 2x times 2 to the power of 3, right? We are multiplying, our bases are the same, so we add the exponents. This is going to look like this. 2x plus 3, right? And that then is actually going to be your final answer because you cannot simplify more than that, okay? X and 3 are not like terms, so you cannot add them together. So your 2 to the power of x plus 3 is going to be your answer here for rule number 1. Rule number 2. So we are going to be dividing here. So our rule goes as follows. A to the power of m divided by a to the power of n, okay? Because we are dividing, what we end up doing is we minus our exponents. So this is how it's going to look. A to the power of m minus n, okay? That is going to be the final rule, okay? So what has actually happened here? Because our bases are the same, what we can do is we can take this exponent and we've moved it up. Because it is a positive down here, it becomes a negative when we move it up. And the same goes vice versa. If we're moving anything across this division line, the sign is going to change. This is super important. But for now, that is rule number 2, where if you are dividing with the same bases, your exponents are going to be minused from each other. Cool. So let's dive into an example here really quickly. Let's say we have x to the power of 5 over x to the power of 2. Okay, so we are going to minus, we are going to take this 2 and we're going to bring it up and we're going to put a minus on it. So this is going to equal x 5 minus 2. And we can simplify that even further. So that's going to be x to the power of 3. That's then your final answer for this rule. Cool. Let's dive into a second example, also super easy peasy. So let's say that we had 3 to the power of x over 3 to the power of 2. What I am going to do is take the exponent and move it up, okay? So how that is going to look, it's going to be 3 to the power of x minus 2, okay? And that then is your final answer there. You cannot simplify any more than that because x and 2 are not like terms, right? So we cannot minus these from each other. So that basically just means that 3 to the power of x minus 2 is going to be your final answer there. Awesome. Let's dive into rule number 3. It goes like this. If we have brackets a to the power of m bracket to the power of n, if we have brackets here, okay, and we have an exponent outside the bracket, it means that we need to multiply this exponent with the one that is inside the bracket, okay? So how that ends up looking is as such. It is going to look like this, right? A to the power of m times n, okay? That's what we are looking for. So let's dive into a quick example. Let's say that we had x squared to the power of 3. Right, what we are going to do is we're going to multiply this 3 in the bracket with the 2. So we're going to be left with x 2 times 3. That can then be simplified as x to the power of 6. And that's your answer there. Super simple, super easy, right? Cool. Number 2, second example. Let's say that you had 3 to the power of 2, okay? To the power of x, okay? What are we going to do? We're going to take that x, we're going to multiply it with the 2 there, okay? It's going to look like this. 2 times x, okay? We can simplify that and say 3 to x. And that's then your answer there. Moving on to rule number 4. Okay, so it's going to look like this. We have a bracket. A, B inside the bracket to the power of m. So here's what we are going to do. Let me just find myself a little yellow color here. Here's what we're going to do. We're going to multiply this exponent with the exponent above A and with the exponent above B. So something that you need to remember here is that there is always a invisible 1 if there is nothing there above your number, okay? Anything is always to the exponent of 1. So what this is going to look like is going to be A to the power of m and B to the power of m, okay? That is the rule. Cool. So now let's dive into a quick example. Number 1, let's say that we had, let's see, x, y, 3. Let's do an easy one. Okay, so what we're going to do here is we're going to multiply with the 1 on the x and with the 1 on the y. There is an invisible 1 here, right? So 3 times 1 is going to be x to the power of 3. And then we've got y to the power of 3. That then is your answer, okay? Now we're going to do number 2. We're going to get a little spicy with it, okay? So let's say that we have 2 times 3, okay, to the power of 2 to the power of x minus 1. You see, we're going to get spicy, but don't worry, I'm going to show you exactly how to do this. So what we want to make sure that we are doing is there's actually an invisible 1 there. We want to make sure that we are multiplying this whole thing with that 1 as well as with that 2. Whoa, let's just get our black. Why is it not changing? Okay, do that. Right, so what's that going to look like? So it's going to be 2, right, x minus 1, because times 1 it will be exactly the same, times 3 to the power of 2 times x minus 1. I like to put my brackets there, okay? That's what we're doing. We want to simplify this even further. Got 2, x minus 1. We can't simplify that anymore, right? But we certainly can simplify this over here, okay? So it's going to be 3, 2x minus 2, okay? Because I'm saying 2 times x is going to be 2x, and then 2 times negative 1 is going to be negative 2. And then what we are going to do is leave that bad boy just like that. Okay, and that then is your answer. I told you we were going to get spicy with it, okay? Should we do one more with this? I think it's getting a little bit complicated. So let's definitely do one more because this gets quite complicated later down the line. So I'd rather just go through a few examples with you. So, let's try 2xy, all right, squared to the power of 3. All right, so what we want to do, we want to multiply this 3 with the exponent on the 2, with the exponent on the x, and with the exponent on the y. So what that looks like in practice is we're going to have, well, let's just go back here. We're going to have 2 to the power of 3, x to the power of 3, and y 2 times 3. Let's simplify that. So 2 to the 3, we know that that is going to be 8. X to the 3 is going to remain the same. But our y, our 2 times our 3 is going to give us 6. So we're going to have y to the power of 6. And that then is your answer here. Rule number 5. All right, so this is where the rubber hits the road, where things get a little bit juicy, if you will. So our rule looks like this. We have A divided by B, okay, and this entire bracket is now to the power of m, okay? And what we are going to do here is we are going to multiply m with whatever the exponent is of A, as well as whatever the exponent is of B. So this is what it's going to look like. In this case, the exponent for A is 1. There's always an invisible 1. If you don't see an exponent, there's always an invisible 1 there. And for B, there's also an invisible 1. So our rule is going to look like this. A to the power of m over B to the power of m. Okay, that is what this rule looks like. So now we're going to dive into some examples and we're going to get juicy with it, okay? We're not going to do something super easy. We're going to step it up a little bit. So first example, let's say we have x squared over 2y right to the power of 3. What we want to do is multiply this 3 with the 2 there. We want to multiply the 3 with the exponent above this 2, and we want to multiply it with the exponent above y. So this is what it's going to look like. X 2 times 3 is going to give us 6 over, okay? 1 times 3 is going to give us 2 to the power of 3. And then we've also got a 1 here, so 1 times 3 is going to give us 3. Right, so now all we need to do is simplify, and we want to simplify that bad boy, okay? So we're going to have x to the power of 6, 2 to the power of 3 is going to be 8, and then we've got our y to the power of 3, and that is our z. Nice. Okay, example number 2, let's kick things up into a higher gear. Right, so let's say we have 3 to the power of 2x over 2 to the power of x plus 1, all in a bracket, to the power of 2. All right, so what we're going to do is we're going to multiply 2 with 2x. We're going to multiply 2 with x plus 1. Okay, so it's going to look like this. 2x times 2 over 2 in brackets x plus 1, because this whole thing needs to be multiplied, right? Times 2. So now, next step's going to look like this. 3 to the power of 4x over, okay, 2 to the power of, what do we need to do here? We need to multiply by the x and multiply by the 1. So we're going to have 2x, okay, plus 2 over here. All right, so 3 to the power of 4x over 2 to the power of 2x plus 2. And this is going to be your answer at this point, because you cannot simplify any further. The reason being, because of that plus right there. Okay, you cannot simplify, you cannot cross cancel anything, because there's a plus there.